All right, in this example, we're going to roll a pair of dice and observe the number that falls uppermost. All right, so let's imagine we have a red die and a yellow die, okay? And basically, all of the possible outcomes are shown over here graphically. Really, we've kind of got a nice picture of what could possibly happen. We could get a 1 and a 1. We could get a 2 and a 1. We could get a 3 and a 1, and so on. Or we could get a 1 and a 2. Now we're going to treat these dice as if they are, the order matters. Okay. And I think I mentioned this before. When you're dealing with dice rolls, in order to get equally likely events, you have to treat the two die as if the order matters. Okay. So that's what we're going to do. We're going to treat the die as if the order matters. Okay. So this is the sample space for our dice rolling, right? We're rolling a pair of dice. And these are all the possible outcomes. I think we had the same sample space in the last lecture as well. So this question asks us to write the following events using roster notation and determine their probabilities. Okay, so the first event we're interested in looking at is the event that the two dice show the same number. Okay, so let's write what that event would be. All right, we get a 1 and a 1, or we could get a 2 and a 2, or we get a 3 and a 3, or a 4 and a 4, or a 5 and a 5, or a 6 and a 6. Those are all the possible outcomes that would meet that criteria, right? It's because they have the same number. And what's the probability of that event? Probability of E, the event E. Well, we have 36 possible outcomes, right? We have a table here essentially that's 6 by 6. So we have 36 possible outcomes. So if each of these outcomes is equally likely, then the probability is 1 out of 36. The probability of any one of these rolls is 1 out of 36. So we're just going to add up. We've got 1, 2, 3, 4, 5, 6. So we're just going to add, 136 plus 1 over 36 plus 1 over 36 plus 1 over, 36. 1, 2, 3, 4, 5, plus 1 over 36. Okay, we're just going to add up the probabilities of each of the 6 individual simple events. Okay, so it's really 6 times 1/36, right? So, so that gives us 6 out of 36, which can reduce down to 1/6. Okay, so the probability of rolling 2 die and getting the same number on each die is 1 out of 6, 1/6. The next scenario, next event that we're looking at is we're looking for the case where the sum of the 2 die is 6. All right, well, let's find that in our sample space. The sum of the 2 die is 6 is along this diagonal here. Whoops, there we go. Right, so we can list the event. Now I'm going to define this event to be F. And I can just list all of the outcomes that give me a 6. So 5, 1, 4, 2, 3, 3, 2, 4, or 1, 5. Okay, put curly brackets around it. So that's our event. And so what's the probability of that event occurring? Well, again, each of these outcomes is equally likely, so I can just add the probabilities of each of the simple events. So there's 36 events. Each one is equally likely, so 1 out of 36 plus 1 out of 36 plus 1 out of 36 plus 1 out of 36. Okay, 5 times 1 out of 36, right, which is just 5 out of 36. All right, so I can't reduce that one anymore. The next event that we're looking at is the case where the sum of the 2 die is sum of the 2 dice is less than 4. All right, so let's find that in our sample space. So here's, well, it says 4 or less, so I guess it includes 4. So along this diagonal, the dice add up to 4, and then less than 4 would be this whole corner here. Okay, so let's list out the event. So I've used E and F, so I'll just call this event G, and the events are 1, 1, that would be 2, which would be definitely less than 4. 1, 2, 1, 3. Okay, let's see, we'd have 2, 1, 2, 2, and let's see, we got, let's see, I'm going to make sure so I guess I went across here, 2, 2, and then we'd have 3, 1. Okay, so I think I've got them all here. And you can see there are 6 individual outcomes, so that would be 6 simple events that we could create, and each one is 1/36th, has a probability of 1/36th. So the probability of this event G is just going to be 1/36 plus 1/36 plus 1/36, again, like I wrote above, but 6 times 1/36th, which is 6 out of 36, which is 1/6. All right, this last event is the case where both dice show an odd number. So let's define this as event H. And so we're looking for all the cases where we have an odd number. Well, let's just list them. 1 and 1 would be give us 2 odd numbers. 1 and 3, 1 and 5. Okay. Let's see, 3 and 1, 3 and 3, 3 and 5, and then 5 and 1, 5 and 3, and 5 and 5. Okay, so I think that's everything. So it looks like there's 9 outcomes in that event, right? So we could create 9 simple events, and the probability of this event H is just the sum of the probabilities of the simple events, 9 simple events out of 36. And they're all equally likely, so we get 9/36, which is the same as 1/4. All right, I'll meet you in the next video.